right, so what we're going to be looking at again here is we're going to be looking at our third scenario, and we're going to look at this, and it's actually a two-sample proportion test. We'll talk about how we know that in just a moment. So let's suppose that I wanted to determine if the class that used my old way of teaching passed the course at a smaller rate than the class using my new way of teaching. So Group 1 was my Fall 2017 statistics class, and Group 2, my Fall 2018 statistics class. So I wanted to define both of those. Group 1 had 35 students, and Group 2 had 31 students. Group 1 had 20 students pass the class, and Group 2 had 24 students pass the class. After running the test, we're going to find this following StatCrunch printout, and we've got this thing right here. Okay, so a couple things that I want to know, I want to see is that my variable, okay, the thing that is being collected is, or did we pass the class or not? So that's the question that gets asked, and it's either a yes or a no. And so since it's a yes or a no, it's a categorical variable. Now we're going to take a look and we're going to actually compare a categorical variable, did we pass the class or not, between two different classes, 2017 class and the 2018 class. So we've got two samples here, and we're comparing a categorical variable, so that tells me that it is a two-sample proportion test. Proportions summarize categorical variables. So it's a two-sample proportion test. Because we are comparing the same variable between two different samples, or two different populations, rather. Two samples. Sample 1 from Fall 2017, Sample 2 is for Fall 2018, right? And we're going to compare whether or not the individuals passed the course. What's the difference? The difference is the 2017 group, Group 1, had the old way of teaching, and 2018 had the new way of teaching. So now we're going to state the null and alternative hypothesis. So since we're doing a two-sample proportion test, my null hypothesis is going to be H naught. That's going to be P1 equals P2. That is, the proportion of students who pass the class is the same for both groups. Then our HA, my alternative, is going to be P1 is less than P2. Since P2 is my new group, my new teaching group, we're asking whether or not a higher percentage actually passed the course than in my old group. Now my H naught in terms of my sentences is going to be the proportion of students who passed Math 219 in 2017, right? That's the first group, is the same as the proportion in 2019. Notice, proportion who passed in 2019. Notice, 2018, excuse me, that I actually define who it is, right? It's the proportion of students who passed, right? The proportion of students who passed, those are my variables. I define what my variables are when I'm writing out my null and alternative hypothesis. Then my alternative is the proportion of students who passed in 2017 is less than the proportion that passed in 2018. And there we go. All right, now the next thing we want to do is we want to determine whether or not the requirements of the test have actually been met. So it's a two-sample proportion test, so we have three sets of requirements. One, we need a simple random sample. We were stated that this comes from simple random sample, so we're good there. Two, we have to have independence of trials. Now, what we can do is we can kind of think to ourselves, well, was whether or not an individual passed the course independent from student to student, right? And some ways it kind of isn't, right? But for the purposes of this one, let's just assume that it is. We're going to assume independence. Generally, we just look at how big is the sample size in comparison to the population. In this case, the sample size is about the size of the population, right? Our population is 2017 versus 2018. So it's a little bit problematic, but let's just assume independence at the moment, okay? 3 is really where our problem is. If we go back up here, what we notice is the count of those who passed the first course was 20, and the total was 35. So that means 20 successes and 15 failures for group 1. In the second group, we got 24 successes and 31 fails. Oh, excuse me, not 31 fails, but only 7 fails. 31 minus 24, which equals 7 fails. Okay? Well, that's a problem because that's not actually 10. We need both the number of our successes and failures for both groups to be over 10 for us to be able to say that we have our requirements met. So, what we want is successes for both groups are greater than 10. And failures for both groups is greater than 10. But this is not true. So consequently, since it's not true, our results, whatever results we get, are not valid. So I'm actually going to state that in the conclusion. The results I get for this test are not valid. Valid since the conditions are not met. Boom. I've got to meet the conditions. If I don't meet the conditions, that is really the central limit theorem, right? I have to have more than 10 successes, more than 10 failures in order to have an approximately normal distribution. Since I don't in this case, right, I can't actually make the statement that there is a conclusion. I don't have one, right? And then it adds that question, is there a statistical evidence that my new way of teaching is more effective than my old way? Well, no, because my test is invalid. I need a bigger sample. There it is. So something to think about. If it turns out that the requirements of our test aren't in fact met, then you don't end up with valid results. Okay, it's very important. One of the things that ends up happening oftentimes is that people do tests with very small sample sizes and think that the statistics actually match up. It doesn't. All right, it doesn't work. We end up with too many problems. We end up with things like biases or representativeness problems, or even the fact that, we just have a completely underpowered test, what we call underpowered test. So we've got to check our requirements, okay, and then determine whether or not we can actually run the test. Second point here, we've got 2 groupings, right, 2 samples, and they're comparing a categorical variable, so that's a 2-sample proportion test. There it is. That's our result.